Whoa, there we go. All right.
Get closer here.
Yeah. Sorry, it's my some flop sweat.
Yeah.
It's disgusting. I'm sorry. I'm standing right next to Brian Goetz.
Hey.
Did I mispronounce the name?
No, that's right.
Java language architect extraordinaire. Congratulations on Java 21.
Thank you.
It's,
Thank you.
I mean, the single biggest talk I think was the Java 21.
Yeah.
It's like 900 people registered plus several overflow rooms. Yeah, there's a reason.
Yeah. There's lots of good stuff there.
No, that's the understatement of the year. People have seen me do breath. I've done countless videos and countless blogs, countless tweets. I just breathless.
Yeah.
Affection for this new release, and I don't think people really, because it ties the knot on so many themes.
Yeah.
That if you blinked and you didn't pay attention, you wouldn't realize it was much bigger than the sum of its parts, right?
Yeah, it's the forest and the trees thing, right?
Yeah.
We've been seeing features coming into 17, 18, 19, 20, piece by piece.
Right.
And they stand nicely on their own, but a lot of the themes, that tie together a lot of these features have come together in 21, right? So 21 completes the first arc of algebraic data types and pattern matching.
Right.
And so, I had a code example at the keynote, which is the same code example I showed 4 or 5 years ago at my last keynote at Devoxx. But 4 or 5 years ago, it was total fantasy, right? It was like, it was a whiteboard example of this is what I'd like Java to look like. And 7 JEPs later, this is real code, and it all fits together.
And countless amounts of people, countless of effort and work, and yeah. Okay, so let's talk about this. Oh, okay, thank you. So let's talk about this. Obviously, the thing that you could most obviously miss if you're not paying attention is loop.
Yeah.
Like I know everybody knows about it, and for good reason. But it's also one of those things where if you're just looking at some code from 20 years ago, and somebody added one of platform versus of virtual,
right?
That's the only thing that would have changed in 20 years, and the code would be exactly the same, but far more scalable. Well, I mean, you did it. It's here now. Well, part of it, 1/3 of it is here, right? The most important.
And the brilliance bloom is the degree to which it changes the API almost not at all. That it reuses the existing thread API. All of the thread adjacent APIs like thread local still work.
Yep.
All the existing code out there just works. And the only change that most people will see to their program is how they configure things.
Yeah, and even there, like if you're using like you can swap out one executor someplace.
Mhm.
It's not a thread pool anymore. It's just a executor.
Right.
You can swap that out. Now you get unlimited scale. Like for free. You mentioned thread locals.
Yeah.
Okay. That thing is really interesting to me because it still works, but now you've got this really interesting thing of like what happens when I have a million of something.
Yeah.
Right. Like I can do a million threads, but do I want to have a million copies of this object? That's the scope values story, right?
Yeah. So that's an example of today's problems come from yesterday's solutions, right? Thread locals worked all right for many years,
right?
But under a certain set of assumptions of there's just not that many threads. There's a few hundred, maybe a few thousand. And all of a sudden, if you have a million threads, those assumptions don't hold. And so old code will work, but it may not have the runtime characteristics like memory usage that you expect. And so we are seeing a couple of things that people who are migrating to Loom run into. One is they keep trying to pool virtual threads, which they should stop doing, but they're so used to it, right? They've been told for 20 years. I mean, 20 years ago, 25 years ago, I wrote articles about thread pools, right? Like, and why they're good, right? And they were because they were useful relative to the thread frameworks that we had. And now the reality has shifted. So people have to get out of their pooling mindset. And they have to reevaluate their use of thread local. But it doesn't mean their code won't work. It may mean that it uses more memory, and there might be a better way to do it now.
Oh, but at least you get the scalability
for
the 80% case.
Yeah.
And even there, I love the fact that with the failure, I'm air quotes, okay, people, air quotes, the failure mode. I like if you do a synchronized block and then do input stream.read, air quotes breaks Loom, but it still just it just performs like it would have in Java 20.
Exactly.
It's an escalator. When
Right.
it's working, it's still stairs, you know?
Yeah, it just spins the thread, but it still works.
I mean, even the failure mode is still great.
No, Loom was an absolute tour de force, I have to admit that, in the early design discussions, I was a little skeptical of some of the claims, people made of, what could be done.
Right.
And I'm so impressed with how it came out.
Me too. So when does and again, congratulations to you and everyone. When does the so the scope value stuff, is that 22 or
So
when do we look forward to that?
Probably 22 or 23. I don't, I mean, it's been baking for a while. It's in pretty good shape. We decided to hold it in preview for another version or two to get a little bit more feedback. But I mean, people do use preview features in production if and if they want to, and that's okay.
I feel seen.
Yeah. No, it's totally okay. I mean, using a preview feature in production is basically what you're saying is, I'm willing to make some changes when the next version comes out,
right,
if I have to. Right. And once you sort of sign to that, that's fine. Do what you're doing.
I mean, even with Loom, there were some over the many years. There were some changes. There were some small changes that were. I remember there was like a method like is virtual or is
right,
whatever,
right.
Small stuff like that. But again, due to its very nature, it's just a thread most of the time. It's always just been a thread. At one point, very early on, we had like a fibers. There's a hierarchy or whatever. But now it's just
it's just a thread.
Changes.
Yeah.
There's nothing there.
Yeah.
It's amazing. So okay, Loom, we got that out of the way. I want to talk to you about data-oriented programming, but first, this class file API.
Yeah.
Is looking super cool.
It is awesome.
And I'm a huge. I mean, obviously, I work on the Spring team. You may not know that. And we have a lot of byte, manipulation, byte code manipulation, and that kind of stuff is. I don't know. What can you tell us about it? What is it? And
yeah, so for years and years, almost everybody used ASM for byte code manipulation, for generating, parsing, transforming class files on the fly, proxy generation, things like that. And we do that in the JDK, right? When you evaluate a Lambda, you get a Lambda proxy class. We spin it on the fly in an invoked dynamic bootstrap using ASM.
Yeah,
and we've been doing that for years, and it works fine. The problem with ASM is not that it's not good. It's fine.
Yeah.
It's that it's only loosely coupled to the JDK, which makes sense
as a library.
But as we're evolving the class file format more rapidly, the delay of the version of ASM that supports JDK 21 doesn't come out until after 21, or you bundle a version of ASM with your application and it doesn't know about 22, 23, 24. And so we decided it was time to put a class file API in the JDK. And this is something that we've been working on for 4 years. I mean, we had just started working on it the last time I was at Devoxx. It's 4 years ago.
Oh, wow.
So it's been a long time coming. And we knew there were a bunch of things we knew about it when we started working on it. We knew that it was going to make heavy use of pattern matching.
Right.
Java didn't have yet at the time, but we knew where we were going.
Right.
And we had a set of requirements for what we wanted the code to look like. And it just came out fantastically. It's just a beautiful API to work with.
It looks like it. I only saw the talk at the JVMLS.
Yeah.
But when does that become a thing we can all play with?
So it actually went into 21, but locked up behind a private package. It will preview in 22. And
like 3 releases after that.
And probably 2 releases after that. It'll be GA.
Amazing. Again, most people on this stream probably don't care. And as well they should. The JVM does its magic without you having to manipulate bytecode.
Exactly.
But it is just such a nice, wonderful thing to have. And it'll open up. Because I don't think people know that this is a thing they can do because they don't necessarily go to college and then learn about bytecode manipulation.
Right.
But if it's in the JDK, it'll be in some.
Well, if it's in the JDK, it will be co-evolved with the VM specification, and that's the key thing.
Right.
And as we evolve the VM specification with new features, like when we add new attributes, like for sealed classes, we can immediately implement it, in the API, and have tools be able to recognize these new attributes immediately.
So cool. Okay. Huge, big deal. And it might be one of those things you just never know. You know, in a few years, all the things you're using that do these kind of things, they may not need them anymore, which is a huge deal. Okay. Now, obviously, we talked about it. We teased it because this is one of those things. I read your phenomenal blog or article from the InfoQ.com last year, 2022. For those watching in the far-flung future, you talked about data-oriented programming, right? A new kind of dispatch, and you said in the world of the large monolithic code bases, Java was king or queen, or it reigned supreme because it had all this protections for modularity and privacy and boundaries and all that. And now there's this sort of removing the smaller surfaces, and the dispatch is no longer along the object boundary of these deeply seated hierarchies, but instead the messages that you send between things, and it makes sense for language you need to evolve that. Right. That. What is that? So why this instead of like having a weekend to yourself?
Object orientation was subject of a huge amount of hype in the early 90s. And so Java was born, in that time, and we had very optimistic ideas of how it was going to save us from complexity.
Do you remember WordPerfect? I think it said now object oriented or whatever.
Yeah.
On the box,
right? Right. Exactly. Yeah. And it was the right technology for the applications we were building at the time, right? Yeah. It's like you couldn't have built WebLogic without it.
No.
And so a lot of the Java language design is built around supporting large, moderately coupled applications. Right. Which is described like all the important applications from 15 years ago. Yeah. So it was great. And that's why Java really caught on there. But the world has changed. We're building smaller applications, building smaller services. They're not Java end to end. And that means we don't get to model our data end to end using Java objects. Right. We have to deal with untyped data being fired at us in the form of JSON or YAML, or dealing with untyped data from databases or what have you. And the language has to get better at modeling plain old data,
right,
and expressing polymorphic operations over plain old data. And so we took a page from the functional community, which use algebraic data types, some types and product types, as their only abstraction mechanism.
Right.
And it's a really powerful mechanism. And we put Java's spin on it, which was to make it nominal, right? So
what does that mean, nominal?
So like in languages that have tuples, you have a type like tuple of int and int.
Right.
Well, what do those ints mean? I don't know. They could be the start and end of a range. They could be latitude, longitude. They could be anything. And it's easy to make mistakes where you assign an int to an int, but they're not describing the same thing.
Right.
So Java's tuples, which we call records, are nominal. They have names. The record has a name. The components have names.
Okay.
And we do this because names are helpful. Names make code readable. And so we have nominal tuple types, or product types. We have sealed classes, which are nominal sum types. And together, this forms algebraic data types. And the natural way to express operations over algebraic data types is pattern matching.
Right.
And when we started working on pattern matching, people were kind of confused about what are you doing this for? Is this just a cool syntactic hack so I don't have to cast this thing?
Right.
And I was like, well, that's a benefit.
It's a start.
But that wasn't the point. The point is to be able to deal with data as data without having, because objects are great for what they're good for.
Right.
If I want to just describe a name with a first name and a last name, I don't need an object. I need data. I need a better way to describe data. And so that's where all these features have come from. And one by one, we've been adding them, and they're individually nice, but when you put them all together, some really cool stuff happens.
So when you talk, I agree. I heard you. Obviously, I agree. Talk about dispatch. You use the word polymorphism, and I confess, not a particular student of language design and all that, I always assumed polymorphism had to do with changing implementations of a given shape,
right,
as opposed to changing the shape, right? And I didn't. And so now you've expanded my vocabulary. Thank you. Because we talk about a record, that's not a hierarchy. That's not the same shape across multiple types.
Right. It's just a leaf.
Yeah.
But so Java already supports multiple kinds of polymorphism.
Yeah.
It supports what's called inclusional polymorphism, which is extension. And it supports parametric polymorphism, which is generics.
Right.
You can think of pattern matching as ad hoc polymorphism, where You're able to say, well, hand me an object of type expression.
Right.
And then I can look at it and say, is it a sum expression? Is it a product expression? Is it a constant expression? And I don't necessarily have to have an abstract method in my hierarchy for evaluate this expression. Hey there.
Hey, Brian.
Hey,
I'll see you later.
okay, good, Brian. It's good to see you. I don't have to have, yeah,
Very popular guy today.
it's inevitable.
Yeah.
I don't have to have an abstract method in my hierarchy in order to evaluate an expression. I can just write a static method
Right.
that gets handed an expression and says, well, I know an expression is one of these 5 things. I'm going to pattern match over it. I'm going to do my thing.
Which it only knows that because the compiler helps it with exhaustiveness, which is the other bit that I've just found so cool. That enhanced switch expression is paying dividends now.
Right.
Uh,
But you can do that even without the exhaustiveness.
Right.
Right. Like you can have a method that gets past an object.
Yeah.
And then you can say, case integer, case string, case array of string, and okay, that's not going to be exhausted, so you're going to have to say default. I don't know what it was,
Yeah.
but that's ad hoc polymorphism. Where you're saying someone's handed you an object, and then you say, well, I know what to do with an integer, I know what to do with a string, I know what to do with an array, I don't know what to do with anything else, so I'll give an error message. But you can do it without exhaustiveness, but exhaustiveness makes it that much more pleasant.
and if I change something a year from now, I make sure the algorithm gets updated in kind, right? Hey,
Hi.
Nipa, we're on.
You're doing something.
Yeah. This is where I bow out and how he interviews you. Okay.
What's going on here?
We should do a live stream in a minute too.
Oh, sure. Have fun, guys.
Cheers. Small world. You've got a finite set of values. The idea that you can handle it if you know what those values are. You don't need the compiler to help, but it sure makes it better.
Right. And it catches you when you make a mistake.
Yeah, which is great because I make a lot of mistakes, Brian. I make so many mistakes.
Better type checking is a good thing.
I'm a huge fan. Thank you, sir. What's the one thing you would leave people with if you had one thing to share? Like, what is the thing they should be looking forward to?
So I think people should look into read the paper I wrote on data-oriented programming, try to get a sense of why it is we did these things, because they will invariably see, oh, I could do that in my code, and I can make my code better in this way. So, people have been watching these features come in by one by one, and now they, look into how they fit together. I think they'll be really happy.
I couldn't agree more. I'm going to put this link here. I want people are very excited that you're doing the stream. So this person says, they couldn't make it to Devoxx for the first time in 7 years, and they're just glad to hear from you. And
they even live in Antwerp.
They live in Antwerp, and
they still couldn't make it.
Well, I mean, life happens, right?
No, life happens. No, absolutely.
But anyway, I am also equally thrilled that I got a chance to talk to you, and thank you again. Thank you. Thank you, sir. I'll do that. Okay. All right, everybody. Thank you.
Cheers, all. Bye-bye.